Hi, Karl here at I2r POWER. A frequent question we get here is, how can I ensure that I have coolant flow within my cables? We know that coolant flow is important because it's oftentimes cooling critical components within the melt system. Water-cooled power cables are included within the secondary conductor system because they're flexible. And the flexibility allows the furnaces that you're operating to tilt and pour. This movement, however, over time causes the individual copper strands to break down, which allows them to bunch up and nest within the cable and provide obstacles to flow. And we need to keep the coolant flowing. So what we've learned over the years is if we can support the conductor, keep the conductor from collapsing on itself, and allow suspended solids to pass through the cable, we can promote flow. As I mentioned, with movement comes some worry breakage within the copper conductors themselves. And also the hose begins to break down a little bit. You get more kinking in the hose. And one of the things we like to offer our customers, we can move away from a conventional crimp terminal design and move into what we call a solder pocket design. A design like this. This is just a larger version of a solder pocket. This will, at the end of the day, when it's completed, contain 9,000 MCM cross-section of conductor. As we look here, we've grouped these into a couple different scenarios for you to see. This, in the foundry industry, is a very conventional 1.25" ID hose containing 500 MCM cross-section of conductor. This is a conventional crimp design, and then this, we've just enlarged the ID of the hose 1/4 inch to 1.5 inches, and we're able to put a heavy gauge stainless steel core spring inside of it, which you can see pushes the conductor out to the sidewalls of the hose, fully supports it, maintains the helix of the conductor, and it allows coolant to flow at all times. This is a 2-inch ID hose with approximately 1,100 MCM cross-section. This again is another 2-inch ID hose with 1,200 MCM cross-section, and this is 1,300 MCM cross-section, again in the 2-inch ID hose. And all we're doing here is comparing a conventional approach with one that incorporates a solder pocket and a heavy gauge stainless steel core spring. Again, you can see that we're able to helix the conductor around the core spring. We're pushing the conductor out to the sidewalls and preventing it from collapsing and impeding flow. If anything that I've mentioned here today piques your interest, feel free to call us at I2r. We'd be more than happy to take a look at your specific application and see if something like this wouldn't be appropriate for you. Thank you.